Okay, looking at number 68 on homework section 3.2, they ask you to graph the derivative function. And so what you want to understand is for these different pieces, remember we talked about at corners, the derivative is not going to exist. So the derivative does not exist at the corners. Here, x equals 0 is a corner and x equals 2. Now remember, the derivative is the slope of the tangent line. So when you have a linear function, the derivative is just the slope of that function. So you see the slope here is clearly, we go from the point -1, 3 to 0, 0. So that slope is -3. So if we want to talk about the derivative, the value of the derivative from -1 to 0, for x values from -1 to 0, is going to be -3. That's for -1 is less than x, which is less than 0. All right. And so, like, if that's f, we could call that f prime of x. It's kind of fun. It's going to be a piecewise derivative. Now, the slope here, we're at 2, 2, and then we go to 4, 0. So it looks like your slope is, let's see, down 1 over 1, down 1 over 1. So we have a slope of -1 on the region from 2 to 4. So our big question then is just, what is the slope between 0 and 2? And so have you learned the shortcut? Yes, we have learned the shortcut, right? And so we know that if y equals 1/2 x squared, then y prime is equal to 1/2 times 2x, the 2 minus 1, or just the 2's cancel there, and you're just going to have x. So you just get y equals x. Okay, and so now we can just, oops, sorry, I went too fast. We can just graph this piecewise defined function as our derivative. Between -1 and 0, we have -3. That's just a horizontal line at -3. Then we have the line y equals x from 0 to 2. So remember, we have an open circle at 0 because we have a corner. We don't have a derivative there. But like if you put 1 in, you'll get 1 for the function, because it's just y equals x. It's the derivative. And if you put 2 in, you'll get 2. So you have this, the line y equals x, obviously. And then between 2 and 4, the derivative is -1. So we're going to have a horizontal line starting at 2 and going to 4. And we'll put open circles. We're not really sure about the derivative on these endpoints. So derivative doesn't exist at the corners, and you probably want to say you don't really know what it is at -1 or at 4, because we can come in from the left, but we can't come in, well, we can come in from the left at 4, and we come in from the right at -1, but at the point we don't have a limit. Okay, so that was fun.